Alright, ladies and gentlemen, here is the lecture that I promised you on section 15 on quadratic equations, and so I'm going to go ahead and get to it right now. Alright, there we go. So, here we go with quadratic equations. The general form of a quadratic equation is a times x squared plus bx plus c equals 0. We had that in section 12. Now, notice how you've got your basic trinomial there, and so that's the key to get to the point that we can understand quadratic equations. This is the form right here. Now, the next slide is going to give you the formula itself. This is the quadratic formula. Now, the solutions of the general quadratic equation. Now remember, we just talked about the equation here. Here's the equation right there. A times x squared plus b times x plus c equals 0. And of course, our limit that a can't equal 0, and that's it. But this is the quadratic equation. This is it. Now, let's take a look at some specific things here. We got a negative b. Now, look at plus or minus. That's going to kind of tell us that we're going to have like two possible answers. We will plug in the values for a, b, and c, and then add everything, the negative b, to whatever that square root's going to be. And then we can, as we're going to see, use the negative sign. Negative b minus whatever that value is. And of course, we're dividing that by 2 times a. Now, where do we get a, b, and c? Well, just look at it right here. These are basically our coefficients and constants, as we're going to see right here in just a moment. Now, the expression b squared minus 4ac is called the discriminant. Remember, that's underneath the square root sign. Alright? Now, if this value right here is going to be equal to 0, we plug in the numbers for b squared minus 4ac, and whenever we do the calculations, the value is 0, then there is only one real solution. So one value is going to be the solution to that equation. Now, second situation, if that value is greater than 0, so it's greater than 0 from a decimal point all the way up to any kind of real number bigger than 0. Now, there are going to be two real solutions, and remember, we got plus or minus. At negative b plus or minus the square root of b squared minus 4ac. So we'll add negative b and we'll subtract negative b and that value. And so we'll have to do two calculations if that's the case. Then finally, what if it's less than 0? Now, that means that it's a negative number. And of course, as far as we're concerned, a negative square root is not a real number. And so this is beyond our scope of the course right here. So as far as we're concerned, that value for the square root of b squared minus 4ac, if it's a negative number, everything shuts down right there. No solution. So let's take a look at our quadratic formula here. And here's our quadratic equation. Now, we got 2 times x squared plus x minus 2. Well, now we need to kind of plug in our values for a, b, and c. Well, in this case, a times x squared plus b times x plus c, there we go, there's a plus, equals 0. So a would be equal to 2. We have a invisible 1 right here in front of the x, so b equals 1. And then finally, c equals a negative 2. Just as you're going to see right here. There it is. Now, it's now just a process of coming in here now and plugging everything in. Got a negative 1 plus or minus the square root of 1 squared minus 4. Remember, the 4 is a constant here, part of the equation. And then a, of course, is 2. C, negative 2. And then that divided by 2 times a, which is 2. And so we just do the math. And so what we'll have is 1, a negative 1 plus or minus the square root of basically 17 in here, divided by 4. And there's our answer. Now, as you're going to see, we can use a calculator to get like a decimal approximation of the answer for this particular one. And so we'll just go ahead and do the math here. A negative 1 plus the square root of 17. Remember, that's what we came up with that discriminant. And so that would be approximately 0.78078. Now, that's plus that negative 1. Now we're going to subtract it. And now we come up with a negative 1.2808. And so what we have is 2 answers for that particular linear equation. So here we have another one. Negative 3x squared minus is equal to negative 5x plus 1. Well, remember, we got to get all of these values here to the other side of the equation. So we'll basically add 5 here, 5x I should say. So that'd be a negative 3x squared plus 5 is equal to positive 1. And so now we'll subtract 1 from both sides. And so what we're left with is negative 3x squared plus 5x, and we can put the x there, minus 1. That's equal to 0. And so now we're ready to do some business. And so just like we did, they rewrote the equation. And there it is. Now, there's your values for A, B, and C. And then you plug in to the quadratic formula right here. And so what we got is A is a negative 3. B is what, 5? And then C, negative 1. And everything's plugged in here. And notice how this is a negative 5. It's a negative B, whatever B is. and then do the math. Notice how we have a negative 5 plus or minus the square root of 25 minus 12, which would be what? Square root of 13. And so that will be our answer right there. Now, this slide right here kind of tells us that the formula works correctly even though the leading coefficient is negative. Remember how we said that we'd like to have positive leading coefficients. That's not a problem. We can go ahead and multiply everything by a -1 or whatever to be able to get rid of all of the negative coefficient. And so doesn't matter what we do, the answer is going to be the same. They'll have the same solutions once we do the math. So either way, it'll work. Like this one right here, we can just multiply everything by a -1 right here. And we've got a positive 3x squared, negative 5x, -1 times -1 give me a +1. Of course, this would be 0. Same thing, it works. Same value. Now, notice how instead we have a negative, remember that's a -b. Well, negative b is what? -5. So negative times negative works out to be a +5. Still doesn't matter. We come out with the same answer. Of course, they went ahead and did the approximate solutions for the positive and negative values. Now here we got our friends, the fractions. Not a problem. Just multiply everything by 6. Of course, that cancels. This would be x squared minus 6x. And 2 and 2 go 1 time, 2 and 6 will go 3, plus 3 equals 0. And there you see it there. And then this is what we've got. And so A equals 1, B equals -6, C equals 3. Just like you see there. And then we plug in, we're going to wind up with a +6 here. Plus or minus 36. And then I'll just go ahead and kind of 36 minus 12. And of course 2 down 1 to give us 2. We got 6 plus or minus the square root of 24 divided by 2. Now notice how they factored out 24 is what? 2 times the square root of 6, or 4 times square root of 24. Let me kind of come here to the side here. Square root of 24 is equal to what? The square root of 4 times square root of 6. Of course, the square root of 4 is 2 times the square root of 6. That's where this came from. So always be on the lookout to be able to factor out that square root or that radical there. So now, see how they factored out the 2? And that works out to be 2 times 3. They divided 2 into to the 6 to get 3. So 3 plus or minus the square root of 6. Then, of course, our 2's will cancel. And what we're left with is 3 plus or minus the square root of 6. Now, look at this one right here. We've got 2x squared minus 25 equals 0. Now, your square root method can be applied by adding 25 to both sides. Of course, then dividing by 2 and then taking the square roots. But that's going to be the same as just using the quadratic formula with b equals 0. We've got a, we've got c. And so all we do is plug in 0 for b. That's the simplest thing to do. And so we just factor out this perfect square or negative square into a trinomial. And this is basically what we would come out with. And this, of course, is a, b would be 0, c would be a negative 25. And so there you've got your values for here. Whenever you plug in, of course, you see how you got the 0 here. That pretty much changes everything. We've got plus or minus the square root of 200 divided by 4. Now we can certainly factor out the 200. Plus or minus 10 times the square root of 2. Of course, that would be the square root of 100 times the square root of 2. The square root of 100 would be 10. There's where the 10 comes from. Of course, the square root of 2. Then it's just a process of doing the math. Plus or minus 5 times the square root of 2. Of course, you see how they went ahead and reduced the fraction. And so here we've got another one, basically looking at our values for A, B, and C, and then plugging everything in. And so negative 5 squared minus 4 times 2 times a negative 3 gives us 7. And so when we're done, we got 2 values. Now, what about this quadratic equation? What we can do is take the 2 binomials, combine them to make a trinomial, and then subtract 4x from both sides, and that's pretty much what they do. There's a trinomial, 3 times x, 3x times x, 3x squared. 3x plus 2 is 6x minus x, it'd be positive 5x. Of course, we've got a negative 2, and so now we will subtract 4x from both sides, and so 3x squared plus x minus 2 is equal now to 0. And so now we've got our quadratic equation, and now it's just a matter of hooking up our values for A, B, and C, and there you see them right there. And plugging them into the quadratic formula. And basically what we got is negative 1 plus or minus the square root of 25, and of course the square root of 25 is equal to 5. So we got a negative 1 plus or minus 5, and so x equals 4 over 6, or 2/3. Whenever we do the addition, now the subtraction would be what, a negative 6 over 6 or a negative 1. So there it is. Of course, we could have just done the regular old factoring like we did in chapter 12, where we take the two binomials, make them equal to 0, and then do the math. That's certainly a shortcut method compared to using the quadratic formula to be able to do the solving for x. Get our two values. Here, of course, got our trinomial. A equals 4, B equals 12, C equals 9. And so everything's plugged in. And now look what's going to happen. Look at our value right there, 144 minus 144. We're going to be getting the square root of 0, which is going to be 0. And so we drop everything to the right of the negative 12, and so what we have is one answer, a negative 3/2. There's only one solution right there. Now we could also solve it this way. See how it's a perfect square trinomial, 2x plus 3, and that's of course squared. This is squared, this is squared. And of course, subtract 3 from both sides. Of course, set it up as a quadratic. Divide both sides by 2. X equals a negative 2/3, of course, and that's going to be a double root solution right there, like we talked about in 12.6. Here we got another one for a non-real. Everything's going to be 1. And see how we've got our values here. And so when all the math is done, we're going to wind up with a negative 3 right here. And so there's no real solution. So when you're going to have a negative value in there, no real solution. So this wraps up this particular little lecture. And so I'm going to go ahead and give me a moment here to kind of shut everything down. And when I get back Thursday, we will review. I also got an email today that said that there is also another practice final from our department head that you should see in Hawks. And so that's just another set, of practice problems for you to be able to do to kind of get the feel for how the final is going to go. I can't touch any of those values on her practice final. Everything's locked, but you can take it as many times as you want and practice as much as you want. So I would highly recommend that you take advantage of that. And so I'm going to see what I can do about shutting this video down, and I will be looking forward to seeing you all next week.